Thanks, Savas. Good evening, everybody. Thanks very much for joining. I'm Paul Wheels. I'm the organizer for IoT North. So this is the first one of bringing Newcastle and Manchester together and starting to build out IoT North. So welcome especially to, oh no, Steve, I've just seen your, that's shocking. Welcome. Thanks very much for joining us. I was really pleased that I was able to grab IoT Manchester meetup and bring it together with Newcastle. I think it's an awful lot of stuff that we can do together as the two communities coming together. The plan for the foreseeable future is that the meetups will be virtual, which really helps us getting people like Rodolfo to be able to present, being internationally based in Barcelona. Moving forward, once we're all allowed out to play, then we'll rotate between the two locations of having them in Manchester and Newcastle, but continuing to have virtual access as well via Zoom. Excuse me, where are we at? Okay, so IoT North is sponsored by Go250. Go250 is my community that I created as part of AD Link technology, edge computing business. We make hardware and software. The community is designed to enable machine vision, AI, and edge computing as a community to help accelerate its adoption as part of the IoT ecosystem. Please do check it out. It's new. It's been around for about 6-7 weeks now. The content is not just provided by AD Link, it's provided by the community. There's also a forum there to share your insight, ask questions, support where people need support, but also ask questions and gain support as well. And together, hopefully, accelerating everything. We're also sponsored by Newcastle University. Savas on the call here, who's kindly providing the paid for Zoom service and event space when we get back in person. Savas does have a survey that we're trying to get as many people to complete as possible to help understand and enable the university to do some analysis on what may be stalling the adoption of IoT, or what's working well, what's not working, and the business challenges. There is a link at the top of the chat, which I'm going to copy and paste again so it's relevant to right now. Oh, there we go. Savas has already done it. If you could please take a note of that link. We have shared it via email over the past couple of weeks to everybody, but we've had 7 responses out of 2,000 members. If you could please fill it out. It's 9 questions. It only takes about 2 hours to fill out. I'm only joking. It used to before Savas took some feedback on reducing it a little bit. Yep, it's only 2 hours there. So yeah, if you could fill that out, it doesn't take too long, about 10-20 minutes. It would really help the guys. And the guys are really trying to help us as an industry accelerate the adoption, but they need to understand what the challenges are before they can. Okay, so tonight we have Rodolfo. Rodolfo, I am not going to try and pronounce your surname, from Pervasive Technologies. So the structure here is we'll start off with a few questions with Rodolfo that we haven't prepared at all. Yeah, we totally have. Rodolfo is then going to talk us through AI machine vision in practice and what Pervasive Technology have been doing. I had the pleasure of spending a couple of days with Rodolfo in Germany at an event back in February, and had some very animated and fun conversations with him. So I'm really looking forward to this talk tonight. So Rodolfo, 25 years entrepreneur, at C-level experience with strong technical background and innovative leadership. His core experiences in software, e-commerce, and energy international markets. Pervasive Technologies, his business is an innovative company specialized in the construction of predictive solutions through the use of artificial intelligence, machine learning, and deep learning technologies for different sectors. Rodolfo, welcome. How are you doing, sir?
Thank you, Paul. Welcome. Thanks for inviting me, and thanks for everybody to be here.
It's great to have you here. I really appreciate it. So, first question, relevant to what we're all going through at the moment, but also, how did you get into machine vision?
That's something I wanted to explain during my presentation, but the thing, actually, I can say it now. I wanted to transform cameras into IoT devices. So after I'm old. I'm around 53 years old, and after the many years I was in enterprises and startups, I wanted to change my technical direction, and I went into machine learning and deep learning.
Yeah.
Because I wanted to transform cameras, images, videos into information, to get data from that, to transform the cameras into devices, into IoT devices.
Yeah.
That's my main interest. Was my main interest.
What sort of drove that interest? What was the thing that sparked with you to start to move into that direction?
The potential I saw. I saw the potential in reading what the images have apart from the image itself, to get information, to get metadata, to interpret, to understand the things that were in the images, or the actions, or the events, or the elements.
Interesting. So prior to COVID-19, I believe you guys out there in Boston are allowed to go for a walk for a few hours a day now, while being locked down, which is great news. What was the biggest challenges in gaining market penetration for Pervasive?
We are a startup. We are a 14 people startup. And the main challenges to gain this penetration were, I think, two. One, to industrialize our models with hardware that could be deployed at the edge with an industrial, working like an industrial devices with the same level of life and working as other machines that are in the factories, because many of our customers are in the manufacturing area.
Yeah.
And also the other big challenge was to make people understand what we did. I mean, it's very difficult sometimes to explain deep learning, artificial intelligence, machine learning to people.
Yeah.
So especially to IT departments.
Mm-hmm.
So our customers are usually not IT departments, are business departments.
Yeah.
Sales, manufacturing, security, safety, and IT is not our natural speaker on the other side. Yeah.
Yeah.
So these technologies are seen as technology, but are more business than technology.
Yeah.
I mean, you have to talk to the right person in the business area that have the pain that you want to solve with these solutions.
So, excuse me. So it's more, you're finding that actually when you're talking more outcome-based rather than technology-based, you're getting a better response to it?
Can you make me the question again?
Yeah, sure. So I'm sort of taking from what you said there that actually when you talk to customers about outcome rather than the technology, you get a bit better reaction from talking in that way.
Yes, the only one is to talk about outcome, input and outcome.
Yeah.
Because technology is not the important thing here. The important thing is how much they're going to save, how much faster they're going to produce, how more security they're going to have, or safety. Not the technology. We hide the technology. I mean,
yeah.
Our devices are black,
mm-hmm.
okay, and we treat them as black boxes in front of the customer.
Yeah.
We don't let the customers touch them.
Mm-hmm.
We don't want to install in their hardware, computers. Here, the technology, the technical part for the customer must be hidden. At least what we see. We talk about business, inputs and outputs, and how much does it cost, and how much I'm gonna save.
Interesting. Yeah, I'm starting to hear that a lot more with other partners and members of the community are starting to find that, you know, we as a community and as technology providers, we talk overly about the technology because we're very passionate about it, because we understand it. And sometimes we forget to talk about the outcome and the value that customers are looking for. And I think businesses are starting to see that actually they need to, as you say, it's a black box, don't worry about it, it works. This is what it's going to do for you. What's the one thing that you've learned that you think would be good to share with the community? I think that was a great one, to be fair. But is there something else that you would like to share to the community of something that you've discovered that you think is quite interesting?
As you said, it's always related to the same thing. I mean, we learn a lot that this is about business. This is about business, and you have to transform what you do into a business language with the output and the input. And you have to understand in this business, machine learning, prediction, artificial intelligence, the most important thing is to pose the right question to get the right answer.
Yeah.
Independently of how you do it in the middle. And posing the right question is not easy usually.
Yeah, yeah, I'd agree with that.
And we spend a lot of time with customers to get these right questions.
Yeah, excellent. I think everybody's gone through that learning curve as well, with it being new technology, about asking the right questions to be able to deliver on that, and with the right response to fit your solution. Yes. Where do you see the biggest traction with customers? What verticals? Where have you guys been succeeding?
We have been succeeding mainly on personal protection equipment detection and classification of different situations in factories. I mean, the industrial area, all manufacturing, logistics, there is a lot to be done. And everywhere there you can find personal protection equipment like hard hat detection, gloves detection, reflective vest detection, because you find this everywhere. Construction, manufacturing, logistics, transit. And there we have found a good traction, a very good traction. And we hope now with COVID, we are going to have a third area with good traction also.
Yeah. Okay, excellent. Hey, I think that leads on to your presentation quite nicely. So I'll stop sharing and let you fire away.
Okay. I expect this to be an informal meeting, as always the meetups are. So I'm going to jump in between different concepts. Please ask whatever you want and interrupt me whenever you want, okay? So I'm going to share my whole desktop. Oh, Zoom doesn't let me share the desktop. Let me see, 1 second. We didn't try this before. I have to go out and in, he tells me. I'm sorry, Paul. I think to be able.
Rodolfo, just giving you a host right, so you may want to try sharing your screen once more and see whether that will work.
You're on mute, Paul.
Has Rodolfo dropped? Apologies, guys. I think Rodolfo's just dropped to log back in so he can share his screen. I'm sure he won't take too long. This is the moment I wish I had that hold music I was talking about earlier.
You get the greatest.
You can always sing us a song.
Have you heard me sing? Hi, Rodolfo. We can't hear you. You're on mute, I hope. Yeah, Rodolfo, you're on mute.
Okay, sorry. I
No
had
problem.
to go and come back for the preferences. Yep. So I'm going to start showing you the video. I'm going to share my screen, full desktop, share. I'm going to show you a video. Are you seeing this kind of restaurant? So this is the main lead where we go, what we do, okay? So this is a restaurant. This guy goes with his tray to a self-checkout device, and you're gonna see how the device recognizes the plates and he can pay without any other interaction. Okay, a lot of noise in the background, okay? But you will use, what you saw here is what we do. Using cameras, normal cameras, and devices, like in this case, a GPU device embedded into this cash machine. The guy shows the tray, the device recognizes the plates. You couldn't see it, but there was a list of plates in front of him in the screen. He paid and he went away. This is the kind of thing we do, okay? So I'm going to explain you a little bit about Pervasive, who we are, what we do. Let me go forward. Are you seeing my screen?
We are.
Okay, thank you. So what we do is we do artificial intelligence, applying intelligence to videos and images. We are a very small company. We are a startup based in Barcelona. Nice place to be, you know. We are 14 people. We do solutions on videos and images, mainly. We have customers in Spain, France, Portugal, Europe, in all Europe, mainly European countries, but also in South America and now in the States. And we mainly work with partners, okay? We have a network of partners that incorporate our solutions into their own solutions, okay, many times. We started in 2016 when I founded the company with one of my partners. I wanted to do transformation of cameras into devices with recognition of scenes, objects, actions. And we started working on that. And from then, we designed our first solutions the first year, 2017. Then we moved into some pilots and POCs in 2018. Some of those POCs transform into pilots or products in production. And now we have many solutions that incorporate our artificial intelligence in production in these countries that I told you, okay? So we can use available cameras. We can connect our edge devices to available cameras and process the images, the video, the streams locally at the device. We are very NVIDIA oriented. We work a lot on NVIDIA devices. And the information that we extract from the images can be sent to the cloud, can be sent locally for monitoring, can be sent to other systems or processes to be used. We can also process in cloud, but this is few cases. We mainly work on edge. We have been working on edge since the beginning. At the beginning, we started with Raspberry Pi. We know that you can do many nice things with Raspberry Pis, but for industrial processes, for industrial environments, we needed something more robust, something with a GPU integrated. And what we did is we started working with NVIDIA Jetson devices, specifically hardware manufactured by AD-Link, a partner of us that works on these NVIDIA Jetson devices. We have customers in different sectors, like steel production, energy production, insurance, food, etc. I'm not going to make a commercial presentation. We chose a specific group of partners that could help us build our platform, and our platform in the cloud, and our platform in the edge. Because for training, we use the cloud. We don't use local GPUs. We use cloud for training and GPUs in the edge for prediction. So we chose Google Cloud, and we use TPUs, GPUs for training on cloud. We chose NVIDIA GPUs for the edge deployments. AD-Link as our hardware partner for the industrialization of the Jetson GPUs, and other partners that provide other pieces of our puzzle, because what we have is a puzzle. It's two solutions that are made from pieces. I will show you the architecture after. So our main drivers today are PPEs, PPE detection, for compliance, for access control, for auto check-in, and for automated access systems. That's a camera or a group of cameras that can detect the usage or how the person is wearing the PPEs, yes or not, hard hat, glasses, protective vest, gloves, boots, the different pieces. That's why sometimes we need more than one camera, because we need different views of the person. and I'm going to talk a little bit more about this case later, and classification for material sorting, for object classification, for systems that detect if a specific situation is happening or not with a product, with a truck, with different manufacturing scenarios. We do also behavior analysis for driver analysis, for specifically for trucks in factories or in mines. Workstation occupancy, people is at the working place or not. Wandering analysis, if people is wandering around instead of working. Accident detection. Dangerous situation detection also we are doing now. And this is for behavior analysis. In the same environment of the factories, we do traffic analysis, vehicle detection, counting, how the anomalies in traffic. And we do ICR. ICR for us is intelligent OCR, optical character recognition, okay? And we do it with deep learning. All these solutions are based on deep learning. And the nice thing is we do ICR in what we call extreme environments, like there is a mill with a ladle, like the one you see with the liquid steel, and we read the number, the tag, the plate of the ladle, so it can be, this information can be sent to the SAP system, for example, to say which ladle is now putting the liquid steel into the press or wherever it is going. Okay. The main solutions from us today are the first two, PPE and classification. The rest are solutions that can be applied to the same environment, usually factories, and they complement the main solution of PPE and classification. So PPE compliance is a very, very interesting solution for safety and audit. We work with normal CCTV cameras. The cameras can be connected to access control devices. They can be connected at the entrance, or they can be in a corridor in the factory. And we can detect the different pieces. We generate alarms or events in case it is necessary to alert the person or somebody that is in charge that there is a non-compliance situation in the factory or at the entrance of the factory. There are other solutions we do, like product detection, satellite image analysis, OCR. I wanted to come here. I wanted to come to our architecture. We use all the power of Google Cloud today, and we use the different pieces that we can find in the puzzle of services provided by Google Cloud. So we use mainly TensorFlow. Our main tool is TensorFlow. And when we work in the cloud training our models, we use pure TensorFlow. When those models go to the NVIDIA devices, they are transformed to TensorRT, the equivalent of NVIDIA for TensorFlow. TensorRT is more optimized to run the models in the edge. And we can run those models in different kind of devices, like in this case, this AD-Link DLAP Jetson power devices. We can run on cameras that have the GPU integrated, like the Neon J, etc. All the information that comes from the devices is sent by Q to the cloud and can be used after for dashboards and different applications that can be connected in the factory or in the customer that need the information that we extract from the images. Okay, this is the cloud part. In the cloud, we do the training, and we collect the information from the devices that run the models. There is another part that is the edge part. On the edge, our devices run on Docker. They have different Dockers with different functionalities. Each model has its own Docker, where we have the NVIDIA libraries, the TensorFlow, the TensorRT, some OpenCV, typical image processing libraries, and we run that Docker with its own modelizer server that runs the model. On top, that's on top. The models that run on the Dockers are on top of NVIDIA libraries, VMS server. We have we install a VMS server in our devices, so we can do remote debugging and control of what is happening with the cameras that are connected to the device. We can do it, or the customer can do it. I mean, if they want to audit why or what is happening in front of the camera, why the results of the predictions are not good, or why specific situations are happening, they can connect to the devices through this VMS server. It's a standard VMS server from our partner Network Optics that is specifically oriented for artificial intelligence. This VMS can work very well with metadata that comes from the models, can show alerts. I will show you a video how it works. And then we have also a configuration server in our devices, a remote control server, and an IoT connector service to send the data to the cloud. So we can send data, we can send errors and bugs, inference results, video stream, and IoT information to the cloud. Our platform is called Heureka. Our cloud platform is called Heureka. So all this information can be sent to our Heureka platform. You can connect with a computer with your devices to the Heureka platform to see inference, video, results, etc., to change configuration. You can also do, and we can also do, setup remotely to the devices, updates to the models, updates to the operating system, and remote control and debugging. So it's a two-way bidirectional communication with the devices. That was one of the challenges, because when you do a rollout of devices in the edge, you lose control of the devices. They can be far, they can be in a specific complicated area where you cannot enter because of the conditions there. So we needed something, we needed a solution that allowed us to control remotely the device, to have all the information of what was happening inside the device in front of the camera, and to be able to change totally the configuration, the setup, even the operating system of the device remotely. And that was, it took more than a year to us to build this part of the platform, the edge part, but it's very important when you do this kind of deployments. For example, in the food detection solution that I show you, in the trays detection solution, we are talking that today we have 12 restaurants working with that solution. And this is developed with a partner. We provide the artificial intelligence part, they provide the hardware and the service. They want to do a deployment of 1,000 units in 1 year. I mean, if we have to deploy 1,000 models in devices, in different places, in restaurants, etc., we needed a 100% trustable platform. It had to be robust, it had to be controllable, it had to be very, very trustable for us, okay? So this is the solution I was talking, the one about the trays that recognizes the food. We have, the partner has 2 different main customers, so Dexon and Amark. These are chains of canteen, schools, hospitals, restaurants. They have they manage those restaurants, and they want to reduce the cost of personnel in those places. And they want to reduce 2 things: the cost of personnel, because there is no human cashier now at the restaurants, and they wanted to reduce the waiting time for people. The experience in time of self-checkout is 3 times faster than doing with a person as a cashier. So people hate to be in queue, to pay for your food at lunchtime in your factory or in the office, when they have just 30 minutes to have lunch, and the sooner they finish, the sooner they go to work, and the sooner go home. So the best output of this is reducing the waiting time and reducing the cost of personnel. The other main solution that I was talking before is the PPA detection solution. And in this case, you can see the solution this is actually in England and in Spain today. You can see a self-checkout kiosk, red and white, with a screen, 3 cameras. There are 3 cameras, one in the bottom, a very small one in the, I think I can draw here. A very small camera here for the boots, a camera here for the face and the head, and there is supposed to be another camera here, but it's not in the device, it's in the roof, because these devices are not waterproof, so they have to be under a roof. So there is a ceiling camera that checks from the top the guy, like this. There is the front camera for the face and the feet camera for the boot. This same solution, this is for auto check-in. I mean, you're a truck driver, you get to a factory, you have all the load in the truck, so you don't have to register with a person. You just go to this kiosk, you go in front, you say the number of delivery you are bringing, you put it there, so the system knows if you can go in or not. And if you can, it checks for your personal protection equipment. And if you are correct, helmet, reflective vest, gloves, and boots, the barrier opens and you go up into the truck and you go into. So this is a very typical application of our solutions with an edge device. This is device from AD-Link NVIDIA powered that is inside the kiosk, and everything is in place working on the edge. No cloud connection in this case, just check-in in the device. And I don't want to bother you anymore with this part, so I'm going to show you the kind of detections we do. I don't know what Zoom is telling me. So 1 second, it's something about Zoom. 1 second. Let me see if I have to say yes. No, it's okay, man. What do you want? Okay, forget it. So I'm going to show you a video about the kind of detections we do. So you're going to hear. I think my friend Paul already saw this video. So let's go. This is the VMS server that we run into the devices. In this case, these are different feeds, but you can get the idea of what the different detections we do can do. Personal protection equipment. It's like a nightmare of boxes, but you can see what we detect. Person, helmets, vests, in this case, reflective vests. People, counting people that passes in front of, in this case, of a shop. Plate detection. This is a very fast video, this part. Amazon has no stuff. Yes. There are today. There are other. I will talk about other solutions now if you want. This is for counting people that goes out from a train station in Barcelona. This is a demo of car detection. This is not very interesting. We have some traffic applications for some customers. In this case is car counting in I think it's in Malta, or I don't remember really, but I think it's Malta, yeah. Car detection and counting. This is nice. This is for a mine. This is the detection of the behavior of the drivers in the mine. So this is a truck, huge truck that is in an open mine. So the guy should be wearing his helmet, and he's not. So the device is detecting that he's not wearing his helmet. So in this case, an alarm is sent to the manager of the operations to say the guy is not wearing the hat. Let's wait a second. I think he's going to come back. You see, there is a guy coming back wearing the hat. And now when he takes the hat, you get the no helmet alarm. This solution detects other things, detects if the guy is talking on the radio while driving, that's something that is forbidden, if he smokes, and if he's not wearing his reflective jacket. So these are different examples of what we do. Okay, this is for PPEs, etc. So I'm going to show you another one. This is very short. This is a solution to detect if people that is working with a specific machine. In this case, this machine has some gases that are very, very bad. So when he opens the window, he must be wearing the mask. The window is opening, he's wearing the mask. Okay, there is a false detection there. So if he opens the window without the mask, you get the alarm of no mask. This is very, very dangerous because they already had some problems with people opening the machine without the mask. Okay, so this is another application, typical PPE, the mask, and a specific situation, the window that is open or not. He cannot pass in front of the machine with the window open and without the mask, another alarm, etc. So this is our main business in artificial intelligence. Okay, so now that we have the COVID problem all around, we started working when we were closed at home 8 weeks ago in Barcelona. We said, why don't we do something for COVID? And in the last 7 weeks, the last one was already, in the last 7 weeks, we have been working on solutions specific for COVID. So maybe you have seen other in the market, but I'm going to show you a minimum of what we have done. So applying the same technology to the different things that we could do for COVID. So we developed 4 solutions. One specific solution that detects masks and glasses. Okay, so let me come here. So COVID mask is a solution that detects mask and glasses in people. COVID access control, Eureka COVID access control, detects body temperature and mask. Eureka COVID safety, the same thing, but for groups of people. This is for individuals, 1 person at a time. This is for groups of people. And the 4th one, the nicer one, is social distancing, a solution that measures the distance between people, and if they adhere to the social distancing regulation, that is different depending on the country. And also, if there is a good view, it can detect if people is wearing masks and glasses. Okay, so you can use your existing cameras, or you can use our cameras that are provided in the kit. So this is the COVID mask solution. Just detects the mask. It's a device that it's an NVIDIA GPU device that goes inside this box that can have a screen or not. It can be without a screen. What it does is detects if you have a mask, and if you do, it opens a digital output. And the idea is to connect this to access control systems, okay? So just detecting the mask. If you are inside the factory, if you already passed the access control at the entry and you don't have fever, when you move inside the factory, you have to keep your mask. So the idea of this device is to be put in internal areas where you pass and you have to show your face and the mask is detected, like entrances, corridors, entries to elevators, places like that. Eureka COVID access control is the same, but with temperature. It checks your mask and your temperature. There are two cameras included inside the device that are here, one for thermal, one for visual. They are incorporated into the device and it detects your mask and your temperature. Same application, same use cases. Okay, if you are moving inside or if you are at the entrance of the factory, you can be check for the mask, check for the temperature. These are products with its own casing, and you just install and run it. You connect it through the digital output to your system. They are not cloud connected. It's just open close the output. Eureka COVID Safety is the third solution that is for groups of people, and it contains the device, the GPU device, and the two cameras, a CCTV camera and a thermal camera. Let me see if I can use this. This is the CCTV camera. This is the thermal camera. And this is the GPU. Everything is connected by USB in this case. This is connected by IP in this case. And you buy the kit, you install it, you run it, and you can see it on the VMS that is included inside, the network optics VMS. And the social distancing solution is to detect distance between people. No temperature in this case, just a visual camera. So you can be a Domo or a Ballet camera like this, like this. They are connected to the IP, one of them, they are connected to the IP port of the device, and you get information about the fact that people respect the social distance standard for the place where they are, okay? So these are different small products based on artificial intelligence, GPU, for helping on stopping the pandemic, okay? And I think this is everything I thought we wanted to listen from me. So let me stop sharing. Now I'm not sharing anymore, yeah?
Excellent, thanks Rodolfo, I really appreciate that. A couple of questions that popped to my mind when you were demonstrating the worker safety. How did you work out to place the three cameras? Why use three, not one? So you've got your top, your front on, and then your feet. You know, what was there a particular reason why you decided to use more hardware for that?
Why three cameras?
Yeah.
Why three? Because detecting boots is very difficult from the top. I mean, it's difficult for people. It's difficult also for devices, for artificial intelligence. So we need to detect the boots. We need a very good view of the boots, because you can be wearing your Dr. Martens, and this is not a safety boot. Mm-hmm. But the system can confuse one with the other. So we needed a specific view of the feet. The second idea is if we need to check if they get, because in some factories there were masks. Apart from COVID, In some factories, they wear a mask, and drivers might wear the mask. So if I have the camera on top with the hard hat, you don't see the mask. So we put the camera in front of the guy, one camera in the feet, and one on the top.
Okay. And so that leads on onto the next question is, how did you collect the initial data to start building the models based on that? So how did you validate the customer requirements and then understand the imagery that you would need and the challenges you're going to have? Was that sort of a test it and see process, or how did you validate that?
Okay, we have pre-trained models. During these years, we have been accumulating a data set. In the case of PPEs, for example, or in the case of plates, it's the same. We have been accumulating images from different sources in the last 2 years, and we have a huge data set of images that have been hand labeled, okay? So after having our first models, we started labeling new images with the models we already had to reduce the time of validation by hand and labeling by hand. So we still label a lot of images. What we usually do is we set up the device. Our partners set up the devices at the customer premises with our pre-trained models, and we ask always a week of fine-tuning. And that fine-tuning means we record images, we record video, we get that video, we label that video with our models, and we hand validate that the system is working well. If it's not, we rush to retrain or fine-tune the models with few images. I mean, we do transfer learning. We have the models that are trained with a huge data set can be fine-tuned with few images very fast to add specifics of the customer, okay? So we usually do that. We take images from the customer. Our partners can do it. I mean, our Heureka platform allow our partners to validate the results and to prepare the images to retrain the models.
So then do you enable your customers to push that retraining as a model as well with your software?
Yes. Okay. And you have to think that for restaurants, in restaurants, when you talk about canteens, for example, because we are not talking about open restaurants, we talk about canteens, yeah? So there is a specific menu of 12 dishes per day, to say something, yeah? So you have some classics that are always there, and every day they change 6, 10, or 12 dishes. Sometimes our model have not seen that dish before, never. When they change season, when they change menus of the company. So our models for self-checkout in canteens must be retrained every day. But retrain every day means that when is the starting of the day, the people that works there, the chef, the cook, must show the device one dish of each once. So they usually have an exhibitor with the dishes. So if before putting the dishes in the exhibitor, he put the plate under the device. The device takes some views of the plate and it retrains, fine-tunes very fast. We're talking about minutes, the model for the day, because every day the model is different. The model is totally fine-tuned for that day. We won't predict any plate outside the menu of the day. Because if it had to predict between 1 million different plates, would be a nightmare. It wouldn't work. The accuracy would be very bad. The thing is, we have closed menus, and we know that day that there are only 12 classes. So it must be one of those. So retraining is more a fine tuning than a retraining, but it must be done every day. So show it once, show it once, and the device is ready to predict for the day.
Excellent.
But the pain today is still labeling and preparing the data. So that's something that still doesn't have a right, clear, cheap solution today.
Okay, I'll open up for questions. I believe there's a few people that have some questions. Aidan, I think you put your hand up first if you'd like to fire away. You're on mute.
That was to stop my dogs barking from coming through. Rodolfo, hi. I've done some programming with Python and the OpenCV2 library for image processing for my own business. I was just wondering, do you hard code each application, or do you have some kind of neural net where you're training it from the images?
Okay, so what we have done is we have adopted GStreamer pipelines, you know, on Python. We work on Python also.
Yeah.
So our models can work. We have a prediction server that we develop on Python that can be plugged with any model that we have.
Yeah.
So the same pipeline, the same prediction pipeline can be used with any model, with some restrictions, yeah, because there are some segmentation, classification, or detection models, yeah.
Yeah.
But let's say that most of our models can be changed in our pipeline and can be plugged into our pipeline in a standard way, so we don't have to redevelop the solution every time. We have our pipeline, the place for the model or the models, because sometimes you work with many models on the same pipeline. We plug them there, and the solution is ready. The most difficult thing here is to get the data and the model trained. It's where you spend more money and more time.
Do you have problems with illumination levels and this sort of stuff? Or is your software compensate? Because that's a big thing for me, has always been getting the illumination correct.
Yes, yes, but it's not the same image processing without or with artificial intelligence. So we have learned that we didn't work on classical image processing before. We just went to the image business with artificial intelligence. And we learned that that was a very big problem on classical image processing with OpenCV and things like that. Illumination, wow, is the most important thing.
Yeah.
When you work with artificial intelligence models, illumination is important, yes, because you have to see what's there, but it's not the most important thing. I mean, when you train your model, you provide it many different images with different illuminations for the same object, and it learns. That's a good thing. It's adaptable. I mean, the model adapts to what you show him for learning. Yeah.
Thank you. That's very good.
So we have the same PPE model that can detect the PPEs on people. I was thinking on a customer that during the night, his cameras go infrared, okay? Yeah. We detect the PPEs on infrared, but we didn't teach the model to detect them infrared, okay? So it's less accurate, but it works.
Yeah.
It works, so and it's a door of a factory. It's a door of a factory, so the sun moves during the day.
Yeah.
So the accuracy is almost the same during all day, independently on how the illumination of the sun is. The only difference comes at night, that we still detect the PPEs with less accuracy. Yeah. So the only thing you have to do is to provide your models with night images at the same time as day images. So it learns. So illumination is not the most important thing.
That's a big advance. Thank you.
Welcome. We have some questions on the chat, I think.
Yeah,
okay.
We have, we'll take Nanlin and then we'll move to Boyang's question. So Nanlin, hi.
Hello. Hi, Paul. I have a quick question. You mentioned that there are transfer learning. You're learning different objects. I know different objects have different criteria for classification. So how are you going to use transfer learning to identify different objects?
Okay, that's a good question. Transfer learning on classification is complicated because you have different classes, okay? But if your model, if your initial model, the one that is trained on the biggest data set, has enough classes for classification, you can reduce the number. What you cannot do is make it bigger. So there is no much problem on transfer learning for classification on less classes than the original. You just don't take into account those that you are not interested. If you do object detection, we usually do transfer learning object detection in the same area. I mean, for example, PPEs, hats, or masks. We have been,
okay, let's do mask, yeah.
let's do mask. What we have done now is masks, for example, for the COVID, yeah, medical masks. We use the model we already had that detected hat, reflective vest, gloves, glasses, and
Okay.
industrial masks. And
Okay.
we only take care with a new model retrained with it after the transfer learning, because transfer learning is you get the old model, you retrain very fast, and you get the new classes.
Oh, I see what you mean. So they have shared the characteristic or features of everything you want to learn. Everything cover the mouse, and then somebody just append something as a mask, look like different, but the functionality is still there. So the main features is you cover your mouse. So the main features still meet the criteria. So you think it's still okay?
Yes, it could.
Okay.
So that's a way to do it.
Okay, thank you. Thank you
Brilliant.
very much.
Thanks, Nanlin. Thanks, Rodolfo. Rodolfo, we have the question from Boyang in chat. Thanks for sharing your idea cases with us. Have you applied the machine vision methods for thermal image, except the skin temperature? Any industrial case, for example, to detect the temperature of machine and the distribution of heat?
Okay, we applied, we didn't know about thermal images until the mid-March when we were closed at home. And we have been working these weeks on, yeah, we apply machine learning and artificial intelligence to thermal images. So what we have done is we have worked on detecting the face of the person in the thermal images, starting with the models that we had based on CCTV cameras. It didn't work very well. So we decided to detect, our solutions have two cameras, one visual and one thermal. So we do the face detection on the visual, and we transfer the boxes that we detect to the thermal to see where the face is and check the temperature. We look for the temperature in the inner canthus. The how do you say, the place where your tears come out?
Your tear duct.
Yeah. So that place is the best place to find the temperature of a person. It's called the inner canthus. So with thermal cameras that don't have artificial intelligence, they don't search for the inner canthus. So they do an average of the face, the maximum of the front, wherever the manufacturer decided is your temperature. And they add an offset, 3 degrees more, 2 degrees more, 1 degree more.
Yeah.
What we do is we go directly to the inner canthus. It's the most similar temperature to your body.
Right.
I would say it's the most similar to your rectal temperature. Okay.
Yeah.
And that would be a good measure. So we apply artificial intelligence to thermal images. Yes, we did. We did this way. We searched on visual images for the face, then applied that to the thermal, went to the eyes, and detected the temperature at the inner canthus. Another thing we try with the thermal images is to detect the mask. But it's very confusing for the models because the colors, it didn't work very well. So we kept the mask detection on the visual image.
Yeah.
So as the two cameras have the same focus, the same direction, the same scene, what we see in one can be applied to the other. So we detect the mask on the visual, we detect the face on the visual and put it on the thermal. And another thing we did, and this is the trick, our solution is based on cheap thermal cameras. If you go to the market now, and if you need to buy a thermal camera, a thermal camera solution for the entrance of your company, university, school, you're going to be spending around 10,000 euros. Because the camera is going to cost 5,000. The black body, that is the reference for the camera, a fixed temperature reference is going to cost between 4,000 and 5,000 euros, and the whole solution is going to cost 10,000. What we did is we made a model to correct the temperature reading from cheap thermal cameras. And when I talk about cheap thermal cameras, I'm saying thermal cameras with a cost of less than 1,000 euros.
Wow.
So if you want, I can show it's not very elegant. Okay, it's because I'm gonna show you. This is the device. I'm gonna take my background. I mean, being in Mars is not the best thing at this moment.
I
So
thought that was just on the outskirts of Barcelona.
no, that's Mars. That's Mars. I'm coming back. So this is Barcelona again. So I'm gonna show you. I'm gonna take the cigarette box I use as tripod. So this is the thermal camera we use. You see, it's a very small devices. I mean, this is my finger. This is the camera.
Yeah.
So it's like a stamp size.
Mhm.
This camera is under 1,000 euros.
Wow.
The problem is this camera has an accuracy of 5 degrees Celsius. But you can improve the accuracy of the camera of the temperature reading.
Mhm.
Okay, if you go to the inner canthus and you apply some models to the temperature output of the camera, and you can put them under a degree. I mean, we are talking about half degree.
Yeah.
Of accuracy. Okay.
Okay.
So this is the base of our solution. So yes, we apply models to cameras. Okay.
Yeah.
The sensor of this camera has the same pixels than the 3,000, 4,000 cameras cost.
Right.
Okay? But it's much cheaper. I mean, the manufacturer of the sensor is the same.
Yeah.
But when you buy this in a box, like a camera with the casing, with the IP connection, with the optics, with all the stuff, you pay 3,000, 4,000.
So going back to the question from Boyang there, have you got any experience in using thermal imaging for temperature for anything apart from human monitoring? So, for example, machine.
No, not for
The
the
answer is
moment.
no. Okay.
We are new on the thermal
Yeah.
arena. Okay.
Yeah. So there's a question from John Hardy here, which, funny enough, was a question I was going to jump onto because he's in this. It looks like he's in the same area that I am. So some of the use cases have production critical safety component. How do you manage the risks with software updates on edge devices? Is it manual intervention to update Docker containers, a la SSH TeamViewer, or is it automatic and continuous? So something like you would do with AD-Link Edge as an example.
Yeah, it depends on the customer. Okay, if the customer allows our devices to be automatically on the situation, it depends on the customer and the case. If they can be updated automatically, and if it's necessary, because sometimes when things work, it's better not to touch them. I mean, if the model is working well, the device is working well, and there is no specific need to update, it can stay there as it is. If we find a specific reason to update the device, it can be done automatically or manually, depending on which is the contract relationship with the customer. Yeah. And it can be done by us, or it can be pushed by the customer.
Yeah.
Okay.
So is that an opportunity in doing the rope management with the edge devices, an opportunity for a sticky relationship with your customer, enabling them with them tools, and also them with their customers, because they can offer a more robust support service, a more robust SLA?
Yes.
Yeah.
There is an opportunity there, and we always propose our customer is the model can stay as it is, and the device, there is a warranty, etc., but it can stay as it is. But if you want, you can manage, I can manage. And one very important thing that provides a lot of value is to detect anomaly situations before the customer detects. I mean, many times we have dashboards with the errors, bugs. We have a bug collecting system that comes from the devices that are connected, okay? And we receive the bugs from there and the anomalies. And for example, it's very typical that for factories, we detect their own anomaly production situations before they do.
Yeah.
I mean, there is a device that didn't collect any image in the last 30 minutes, and it's a continuous line. What's going on? And we check, we see the alarm, we check, and we see that it's a production problem. And our system sends an email to the customer saying, oh, the device is not getting images. It's a problem with the camera, or it's a problem with the production. Yeah. They call us. Sometimes they call, sometimes they check, and they see their anomaly situations because of the device that told us he was not getting images.
Yeah.
And
Brilliant.
that provides value because you are providing information to the customer that he doesn't have.
Yeah. Yeah.
Factories usually are a nightmare. I mean, they are less that automated than we think, most of them.
Yeah.
It's not what we see in the movies. Yeah?
No, it's not.
They are not Star Trek.
Yeah.
And many things happen that they don't know.
Yeah.
Maybe the guy that is there, no, but not the boss. And we detect that. That's a collateral value that we provide many times.
Yeah. Brilliant. Does John, did that answer your question? Brilliant. Does anybody else have any questions? Steve?
I think it's quite related, and keeping in mind what you said about you're trying to do a commercial product for people, you're trying to make them quicker and more informed. And the example you gave where there was the gas and the gas mask and the windows, there's often flickers of false positives or false negatives. How do you handle those situations to give customers, so you don't give them too much noise, you don't devalue what the service you're trying to give them? Because that's an issue we get quite a lot. Do you ever use the AI to try to train it when it was a false positive, or do you just have rules where you say if there's never a gas mask detected within a certain period of time, then it's an alert?
Thank you. That must be done on post-processing. I mean, the video I show you was not the best. I made a mistake. I should have shown the other one. There are no false positives, okay? So, but the real thing is that you get false positives. So if you guys, what you have to do, what we do is when we get the output from the models, a JSON of data every frame, we introduce rules that control how the alerts are sent, how the red boxes are an alarm or are just a transient. So if there is a guy that has the mask, he turns around, you see the back, and there is a red no wearing mask alarm, what we should do and what we do is to generate rules to control that during a period of time, as you said, or to learn to detect the back of the guy. I mean, we can know if the guy is in front, is showing the front or the back, and you're never gonna see the mask in the back. So in this case, the system was fixed after starting to detect the back of the guy. And when we see that somebody is not being seen from the front, is seen from the back, there cannot be any mask there. So don't generate an alarm. But that has a second problem. If the guy comes walking backwards from the beginning of the line, you will never detect the mask. I can't do anything there. I mean, the only solution is to put another camera in front. So every solution usually comes with a problem. Maybe you try to solve something and you generate another problem. Yeah? So, but we retrain. We use new detections and we use post-processing. Post-processing means putting rules at the output of the models.
I was interested if those rules had any AI element as well as the visual cue, because that would be quite an interesting thing where you train it. You say, no, that wasn't an alert. Or do you have to just tweak it for the customer's needs and the situation?
Well, we never, at least myself, I never thought of that, but it's not a bad idea.
I've been thinking about trying to do that as well.
Yeah, that's a good idea. It's a good idea. The thing is, you should be doing a model that works on the output, on the JSON or the metadata, and learn to generate real alarms and not false positives on transient situations. Yeah. It's not a bad idea. Good thing. I write it down. I mean, I like it.
Does that answer your question, Steve?
Yeah, I think it's a bit different because you may be having to learn the models over a longer period than just a snapshot, no mask. It's like over 3 minutes, over 2 minutes, how many JSON events. It's a learning on the the events, like you said, from the visual. So it's a bit of a different model.
Yeah, but you don't need to work on the image. You can work on the metadata of the output. So your model would not need to be so deep. I mean, it could be a classifier that is not based on images, no neural network, XGBoost or whatever.
Just detection rates.
Yeah, yes, just working on the metadata. It's not a bad idea. Thank you. Thank you. Good idea.
Excellent. Does anybody else have any questions? Going once, going twice. Brilliant. Rodolfo, thank you very much for your time. I really appreciate it. I think it's been an absolutely fantastic meetup there. Really appreciate it. Guys, thanks very much. I will be in touch in the next couple of weeks with the announcement who we will have presenting next month, sorry. I think those collaborations work quite well, so I'm really glad with that. Thanks so much for attending. And if you need me, it's paul.wheels, WEALLS, @gmail.com. Another slight little punt, or pitch, I should say. My new product, Visi AI, launched, as most of the Newcastle crowd know, a few weeks ago. I am looking for influencers to take a device and commit to some content. If you want to get started trying out machine vision with the models from available zoos that are running with OpenVino, and would like to start doing some projects, write some content about your experience starting with it, or even if you're more advanced, please do drop me an email. I've got some devices on their way from Taipei over the next couple of weeks that I can give out in return of content, as very much as Rodolfo has kindly agreed to do, and looking forward to getting that content soon from it. Guys, thanks very much, and see you next month.
Thank you.
Thank you. Thank you. Bye-bye.
Thank you.
Cheers.